Thank you so much for joining lesson. We're going to focus on mathematics paper 2, section 1 tonight. So make sure you subscribe. Make sure you share to invite a friend to this broadcast. Share to invite a friend. Share to invite a friend. Let me post the paper that we're going to revise tonight. Yeah, this is what we'll be discussing. This paper, the section 1 of this paper, and all shall be well. Remember, the consultation line for this platform is 0704 153366. So this is the number that you should consult through. Simplify the following Surd, leaving your answer in the form root C for 3 marks. So Surds is a very rich area when it comes to mathematics paper 2, and we're going to give it an approach. Just handle it like any other fraction. Whenever you are doing Surds, please handle it just like the ordinary fraction, whereby you take the LCM of the denominators, and that will be 2, the root of 5 into 2, the root of 2 plus root 5. This is now the LCM. Then to proceed, you just take the LCM divided by the first, and if you divide this by the first denominator, we will get the part with a plus. So we'll be having root 5 root 2 plus root 5. Then there is a plus. The root of 2 will be multiplied by, when we take LCM again, divide by the second denominator, we'll get the part which has a negative. So it will be 2 root 2 minus the root of 5. Then now from the numerator, we can open brackets. We can just expand, whereby we will get 5 by 2 root 2. It will be 2, the root of 10, then plus root 5 times root 5, that becomes root 25, and that is a rational number, whereby we get 5, then plus 2 multiplied by 2 root 2, that will become 2 multiplied by the root of 4, and the root of 4 is equivalent to 2. Therefore, it will be 2 times 2, which is 4. Yeah, 2 times 2, which is 4. Then minus 2 root 2 times root 5, that will be root 10. 10 with a minus. Then we divide this by. Now on the LCM, or the denominator, we're supposed to know that when a Surd is being multiplied by its own conjugate, it's like this is a difference of 2 squares which has been factorized. So a difference of 2 squares which has been factorized can be expanded, and it will give us the square of the first part minus the square of the second part. So it's going to be 2 root 2 squared. That becomes 4 multiplied by 2. Yeah, 4 multiplied by 2, which is 8. Then minus the root of 5 squared, that becomes 5. The root of 5 squared becomes 5. So we can continue now simplifying. We bring like terms together such that from the numerator 2 root 10 minus root 10, that becomes root 10. But there is 5 plus 4, which is a 9. So we'll be adding the root of 10 divided by 3. Now that there is a format in which we are supposed to express the final answer, we divide each separately by 3. So we'll get 3 when we divide 9. Then the second one now becomes a third, the root of 10. Yeah, a third multiplied by the root of 10. So that is how we solve the first question. The second question, which is on logarithms, without using mathematical table or a calculator, solve for x. Solve for x. The log to base 2 of x squared minus 2 minus the logarithm to base 2 of half x plus 5. This is equal to 1. So I can rewrite the equation such that I have the log to base 2 of x squared minus 2, then minus the logarithm to base 2 of half x plus 5. This is equivalent to the logarithm to base 2 of 2. At this point, I have applied the law of logs, which says that when there is a log or the log of a number to the same base, this one is equivalent to 1. The logarithm of a number to the same base is 1. So instead of 1, when I write the logarithm of 2 to base 2, at that point where there is a constant, you introduce the logarithm of the base, the general base used in the given equation. So that's why we have chosen base 2 log of 2. Okay, now we can apply the second law of logarithms, whereby I will say the logarithm of 2, the logarithm to base 2 of x squared minus 2. This one has to be divided by half x plus 5. This is equal to the log of 2 to base 2. The law which has been applied here is log of b to base a minus the log of c to base a is equal to the log to base a of b divided by c. So as long as the bases are the same, you just divide the numbers whose logarithms has been obtained. Then at this point now, we can now drop logarithms because there are no more laws to be applied. We just drop logarithms and we quit the right hand side and the left hand side. From the left, we are having x squared minus 2 divided by half x plus 5 equals to 2. So we can cross multiply to remain with x squared minus 2 equals to, when 2 multiplies everything, half x by 2, that becomes x. Then 5 by 2, that becomes 10. Yeah, this is a quadratic equation whereby we can say x squared minus x. We have negative 2. We also bring 10, which becomes negative. So it will be negative 12 equals to 0. Now we can solve it using the factorization method or any other method of solving quadratic equations. Any other method can be product of a by c, which is negative 12. Then sum is negative 1. So The two factors, which when multiplied, they give us negative 12, and when added, they give us negative 1, are, these two factors are going to be negative 4 and positive 3. Yeah, negative 4 and positive 3. So x squared minus 4x positive 3x minus 12 is equivalent to 0. Then in every two factors now, in every two terms, we factorize. So in the first two terms, we can factorize x to remain in brackets with x minus 4. Then in the other two, we factorize 3. So that in brackets, we remain with x minus 4. This is equal to 0. So from the brackets, we can get the common factor, x minus 4. Outside the brackets, we get the other factor, x plus 3. This is equivalent to 0. So from the first factor, x equals to 4, or from the second factor, the value of x can be negative 3. Yeah, negative 3. So that is it. We are having number 3 now on the equation of a circle, which is again a very common area when it comes to mathematics paper 2. Remember to subscribe. Those are the new entries, the people who are coming to the platform for their first time. Please subscribe and share so that you may invite your friends. I'm also inviting all the continuing students in secondary school to this powerful program, which is going to happen on Google Meet. So remember to enroll by contacting the number which is on the screen. That is 0704 15 3366. You can follow up with that number for inquiries. The lessons are going to be strictly on mathematics and physics. So please make sure that you enroll to the powerful program. Number 3, the question says that the coordinates of the ends or the coordinates of the end points of the diameter of a circle are, one end is A, which is coordinate 3, 2. The other end is B, and that is a coordinate 5, 1. Find the equation of the circle in the form ax squared plus by squared plus cx plus dy plus e equals to 0. You can see a, b, c, d, e are all constants. So the first thing that we're supposed to do here, is to use the ends of the diameter for us to identify the center. We know that the diameter passes through the center. Therefore, when we take the midpoint of the ends of the diameter, then we shall obtain the center of the circle. So the center O, will be given by the midpoint. We take 3 as the first x, plus 5 as the second x, and we divide by 2. Then for the y coordinate, we take 2 plus 1, and we also divide by 2. So the center of the circle is going to be, center O is going to be, this is 8 over 2, 4, then 3 over 2, 1.5. 1.5. That is the center. The other thing to be calculated now is the radius of the circle. Remember, for us to get the equation, we need the center and also the radius of the circle. So for us to get the radius, we just need the length from one of the points to the center. The length from one of the points to the center. For example, we need vector AB, and we divide it by 2, because A to B, that will be the diameter. So when we divide it by 2, now we get the center. Let's see that. We can get the magnitude of AB. The magnitude of AB, whereby we need vector AB first, B minus A. This is going to be 2, 2 negative 1. So that we square 2, we also square -1, and we take square root. So this will be the square root of 5. This one is diameter, which means radius shall be the root of 5 out of 2. Yeah, when we divide diameter by 2, we get radius, and diameter is the square root of 5. So when divided by 2, we shall get the radius. Generally, the equation of a circle is given by x minus a squared plus y minus b squared equals to r squared. Now, from what we have, we should know that AB is the center of the circle. So we'll be taking x minus the a, which is 4, this one squared, plus y minus, do you know that 1.5 is the same as 3/2 squared? Yeah, let me use fractions that way, equals to radius squared. So the root of 5/2, everything now squared. Let's expand the left-hand side such that we will have x squared. Yeah, I'm going to do section 2 also. Thank you for the suggestion. Minus 8x plus 16. That is the expansion of the first part. Plus, now the y function expanded will be y squared minus, yeah, y times -9/4 when you square that part, equal to 5 divided by 4 upon squaring. 5 divided by 4. Then now with this, through by 4, everything by 4, this becomes 4x squared minus 32x plus 64 plus 4y plus 4y squared plus we have -3/4, so that will be -12. -12 y plus this becomes 9 equals to this becomes 5 when we multiply through by 4. Now we can arrange the equation to take the format that we've been advised to. We begin with the term that has x squared, so 4x squared, then plus 4y squared, then the term with 2, then the term with y, -12y. Then now the constants have to be added. So to add up the constants, we need a 64. We have 64 on this side. I remember there was a 9 here. Sorry. This is a 9. It's a 9. So 64 plus 9, then minus 5. That gives us 68 equals to 0. Yeah, plus 68 equals to 0. So that is how the equation is supposed to be. Let's look at number 4, a question on commercial arithmetic. This is appreciations and depreciations. A commercial plot is valued at 500,000. The plot depreciates at the rate of 10% per 6 months. 10% per 6 months for a period of 2 years. It then appreciates at a rate of 4% per quarter yearly for 3 years. Per quarter yearly for 3 years. Find the value of the plot after 5 years to the nearest Kenya shillings. We know when a value is depreciating, we say that the new value equals to P into 1 minus the rate, which is a percentage, raised to n. In this case, P is the initial value. So the new value after the first 2 years of depreciation shall be 500,000 into 1 plus a minus, sorry, this case is minus a rate of 10% raised to within 2 years, but depreciation rate is for every 6 months. That means it's half yearly or semi-annually. It's depreciating semi-annually. So within 2 years, there are 4 halves. And the value here is going to be 328,050 Kenya shillings. That is the worthiness, the value of the plot after 2 years of depreciation. It then appreciates at a rate of 4 per quarter. A rate of 4 per quarter. So we will say that the new value again is going to be, when there is appreciation, new value is given by principal into 1 plus rate, which is a percentage raised to n. So for this appreciation, we're going to take the value it's costing at the beginning of the 3rd years into 1 plus rate of 4% raised to. Now we are told it's 4% per quarter yearly for 3 years. So if appreciation is happening after a quarter a year and we want it after 3 years, then how many quarters will be in 3 years? Each year having 4 quarters, to be 4 by 3. That will be power 12. That will be power 12. Therefore, the value after 5 years is going to be 525,000 to 18.62. But you've been advised to do it to the nearest shilling. So it will be 525,219 Kenya shillings. So that is the value. Yeah, Kenya shillings actually. Kenya shillings. Then number 5 is on statistics 2. Number 5 is on statistics 2. Statistics 2. The data below shows the age of 10 students picked at random in a secondary school. 6, 11, 13, 14, 8, 7, 12, 20, P, and 9. Then we are told if f of x squared equals to 1360, determine the value of P, hence find the standard deviation to 3 decimal places. Standard deviation to 3 decimal places. And now when you look at the values, you're wondering how comes these are students in a secondary school, because we are talking of 6, 8, 7, but in mathematics sometimes you just work out the data as it has been provided. So we are already advised that the sum of f of x equals to x is each age. X is each age. When has been squared, we get 1360. So we shall say that 6 squared, 36. When we add 11 squared, that is 121. Okay, we have to square all of them. 13 squared, which is 169, plus 14 squared, which is 196, plus the next one is 8 squared, 7 squared, 12 squared, 144, 20 squared, 400, p squared plus 9 squared, which is 81. This is supposed to give us 1360. So p, let me work it out here. P squared equals to 100 when you group the like terms together. So that the value of p now becomes 10. So the unknown age of a student is equivalent to 10. Now that we have all the years or all the ages, we can determine the standard deviation. To determine standard deviation, there are several approaches. The first approach, we can even take all deviations which are given by each value and how it has deviated with the mean. Deviation of each value from the mean. So we first of all get the mean. Get the mean. The mean shall be given by when we add all of them and we divide by 10. When you add all of them, you add everything. You add 6, 11, 13, 14, 8, 7, 12, 20, p, which is 10 plus 9, you get 150 over 10. So the mean is 15. We have to get deviations from the mean now. Deviations from the mean. So all the deviations now can be listed. 6 minus mean, we get -5, comma. 11 minus the mean of 15, we get 4. 13 minus the mean of 15. Wait, this thing has to be computed correctly. Sorry for that. We are just getting the exact thing. Just a minute. I have to take 6 plus 11 plus 13 plus 14 plus 8 plus 7 plus 12 once again plus 20. I'm adding 10. Then I'm adding 9. This is 110. 110 over 10. 110 over 10. 110 out of 10. This gives us a mean of 11. So when we are taking deviations from the mean now, each value and how it has deviated from 11. So 6 minus 11, -5. 11 minus 11, 0. 13 minus 11, 2. 14 minus 11, 3. 8 minus 11, -3. 7 minus 11, -4. 12 minus 11, 1. 20 minus 11, 9. 10 minus 11, -1. 9 minus 11, -2. These are the deviations from the mean. Then now something called variance can be obtained. Variance is usually abbreviated S squared. Now variance is given by, for us to get variance, we need summation of all the deviations squared out of the total number of items involved. So all deviations squared, and we add -5 squared is 25, plus 0 squared is 0, 2 squared is 4, 3 squared is 9, -3 squared is also 9, -4 squared is 16, 1 squared is 1, 9 squared is 81, 1 squared is 1, -2 squared is 4, then divided by 10. Divided by 10. This is going to give us exactly 150 over 10, which is 15. So the variance equals to 15. Now with variance, we can see that standard deviation is usually given by the square root of variance. So we need the square root of 15. Okay, that is already a correct answer, root 15, but we've been given an accuracy of 3 decimal places, which means we must get the square root of 15. must obtain the square root of 15. This is going to be 3.373. 3.373 to an accuracy of 3 decimal places. 3 decimal places. Yeah, 3 decimal places. Something else that we can do on the same question, we know that alternatively, we know that standard deviation can be given by the square root of sum of f of x over f squared minus f of x squared over f. This means we need f of x squared, that is the mean now. So 11 110 over 10 squared, then we subtract. What we are having here is 1360. Remember, we had already been given that over 10. Then now we can take square root. So this is going to be 11 squared is 121 minus, let me just confirm that. Yeah, 11 squared is 121. And remember, the formula should begin with f of x squared. F of x squared. I think this is even a quicker method, whereby we can say standard deviation can be given by the square root of, we take f of x squared divided by f minus f of x out of f now squared. Yeah, that way. So we need 1360 over 10 minus 110 over 10, but this one now squared. Then we generally obtain the square root. This is going to be 136 minus 11 squared 121. This becomes the square root of 15, which is also going to give us 3.373 to 3 decimal places. So the square root of 15, I should retake it. Square root of 15, 3.873. 3.873. So that is it. We can now look at another problem there, which is on binomial expressions and equations. Binomial expressions. Number 6, part A. Expand. In part A, the binomial expression expands the binomial expression 2 minus a quarter x raised to power 5 up to the term with x power 3. That means the fourth term. So the first thing that I will advise a learner to do is to list the binomial coefficients of power 5. That is 1, 5, 10, 10. We just needed the first 4 because we are expanding up to the term with x power 3. In the first term, we shall have 2 power 5, but negative a quarter x shall be to power 0. In the second term, 2 goes to power 4, but negative a quarter x ascends to power 1. In the third, 2 will be to power 3, but negative a quarter x takes power 2. Then in the fourth term, 2 shall be to power 2, then negative a quarter x takes power 3. Yeah, that is the term we are expanding to. 1 multiplied by 2 power 5, which is 36. Then anything power 0 is just 1. So we need that 2. 2 power 5, 32. Then the next one will start with a minus, because negative a quarter x raised to power 1 remains the way it is. So bearing a negative, it means the overall charge there will be negative. 2 power 4 is 16. 16 by 5, then multiplied by negative a quarter. That will give us negative 20x. The other one will automatically be positive, because negative a quarter x squared will become positive 1 over 16. So it will be 2 power 3, which is 8 times 10. 80 multiplied by 1 over 16. 80 by 1 over 16 gives us 5. 5x squared. 5x squared. Then minus, finally, we'll be talking of 10 by 2 squared, which is a 4. That's 40. 40 multiplied by negative 1 out of 64. Yeah, 1 out of 64 because of 4 power 3. And that will give us negative 5 over 8. X power 3. This is now the expansion up to the said term. And in the second part of the same, we are using the expansion to estimate the value of 1.75 raised to power 5. So ours is to equate the expansion. Whatever we were expanding is 2 minus a quarter x raised to 5 equals to 1.75 raised to 5. Then with this, we can equate the bases and say 2 minus a quarter x is equivalent to 1.75. Now we can rearrange the terms and have a quarter x being positive here. 2 minus 1.75 becomes also a quarter. And if a quarter equals to a quarter x, then a quarter can simplify and the value of x becomes 1. When the value of x is 1, then now we can substitute it in our expansion, such that we have 32 minus 20 to 1 plus 5 into 1 squared minus 5 out of 8 into 1 power 3. So when you key in this one into the calculator, you'll be getting a 16 and 3 out of 8. But we've been told we estimate to know the number of decimal places is not given. So this is the exact expansion, which can also be 16.375. So this is also correct. So that is how you carry out such an expansion when it is a binomial question. Yeah, when it is a binomial question. So thank you so much for following up to that far. Thank you so much. You can see someone talking about how math paper 1 was good, and that is great. That's great. We can continue projecting paper 2 mathematics, something that I believe shall be great. Paper 2 is going to be great. Number 7. This is a question on the subject of a formula. I believe you guys can see the screen clearly. Make D the subject of the formula. Make D the subject of the formula. We are already given the formula a squared equals to, you can see the square root is general. One plus d squared divided by b squared and minus b out of 3. But everything there is under the square root. So the first thing we shall do here is to square both sides. To do away with the square root sign, we square both sides so that the left-hand side squared becomes now a power 4. Because it's already power 2 and we want to square again, it's to become power 4. Then the root sign now is done away with. 1 plus d squared out of b squared minus b out of 3. Yeah, we can take b out of 3 to the left-hand side such that we have 4. A power 4, not 4, plus b out of 3 equals to 1 plus d squared, everything over b squared. Remember, it is d which is being made the subject. So we can multiply through by b squared, so that the first part becomes b squared a power 4 plus b power 3 out of 3. This is equal to 1 plus d squared. 1 out of d squared. Now that we have 1 on the right hand side, we can choose to remain with d squared alone there. And we take 1 to the other side where there is b squared a power 4 plus b power 3 out of 3. Then now we subtract 1. Yeah, we subtract 1 like that. At this point, we can also bring all the numbers under the same square root, under the same LCM or the same denominator, which is not basic, which is not a necessary step. So we can just say the value of d equals to, we take the square root, remembering plus minus b squared a4 plus b power 3 out of 3 minus 1 out of 3 minus 1. Yeah, that way. That's how we do the question. There is again another good question here. Number 8 on loci. In a paper 2 mathematics, loci is one of the topics which are supposed to be highly expected. Reason being, it is the only construction found in mathematics paper 2. The only construction in math paper 2. Being the only construction, then now we can bank on it very much. Using a ruler and a pair of compasses only, construct an equilateral triangle ABC of sides 4 centimeters on side BC drawn below. Construct the locus of point P such that it's always on the same side of BC as A. Then we also told to ensure that the angle BPC is equivalent to 30 degrees. More instructions are saying that shed the region where Q can be found if Q is outside the triangle and angle BQC is greater than 30 degrees. Let's begin by the equilateral triangle. Already BC is given. So we are going to use the length of 4 centimeters to using a radius of 4 centimeters to make an arc. And you stand on the other side, you also make an arc using 4 centimeters length. With such, you discover that you are having your equilateral triangle. You will have your equilateral triangle. This is going to be our point A. Now with the equilateral triangle, remember all the angles are automatically 60. You don't even to measure or construct any. You don't need to measure or construct any. They are automatically 60 degrees. Now with that, we can go to the next instruction of constructing the locus of points P such that it is 30 degrees. We can use BC to project an angle of 30 centimeters on that locus. Therefore, for us to have 30 centimeters, that's called constant angle loci. For a constant angle loci of 30 degrees, then we need a center with double that particular angle, that is 60, and we are already having it. So when we stand here, when we stand at the center, using the radius of 4 centimeters, and you make a circle. You make a circle like that. Anywhere along this circle will be our P. The reason being, we can use BC to project an angle equivalent to 30 degrees on any part of that circle. And so it is our locus of P. Then the other instruction is shade the region where Q can be found. If Q is outside the triangle and the angle BCQ is greater than 30. You know, beyond the line, okay, beyond the circle P, the angle projected by BC can only be smaller. This is what I mean. Let me explain myself. Let me just explain myself. This is what I mean. If we use BC to project an angle at the circumference of this particular circle, we are getting an angle equivalent to 30. This angle will be exactly 30. But if we use the same if we use the same base or the same arc to project an angle beyond the circle, let's say at a point there beyond the circle, that angle is going to be smaller. This angle is going to be smaller. This one shall be smaller than 30. And that is why I'm saying for the angle to be greater, it has to be within the circle. So the region that we require is the region found inside the circle. This one. Inside the circle, but outside the triangle. So anywhere there, we're going to have our Q. Anywhere there, we shall have Q. Anywhere there, we shall have Q. We shall have Q there. We shall have Q inside there. So that is where Q is located. Anywhere within the circle, but beyond the triangle, according to the instructions provided. We go to number 9. Number 9 is on variations, whereby we are going to have a joint variation question. Yeah, a joint variation question. The question says the mass of a cylinder varies jointly as the square of the radius and its height. If the radius of the circle is increased by 20 and the height decreased by 10, find the percentage change. Find the percentage change in the mass. Find the percentage change in the mass. We're supposed to know that mass is jointly as the square of radius, but okay, and also as the height, which means now we can replace the constant of proportionality with an equal sign, and we introduce a constant k r squared h. That's how they are varying, and that is the original mass. Now the new mass is going to be given by, or before we express new mass, we can take it slowly. Let's take it slowly. We're soon going to be there. Slowly, we're going to say that radius is being increased by 20%. So the new radius is going to be 120% of the original radius. So this is going to be 1.2 of the original r. Then the new height. The new height is going to be, height has been decreased by 10. So it will be 90% of original height, which is 0.9 of the original h. And this is to mean that the new mass equals to k multiplied by r squared. You know, r, the new r is 1.2 of original r, but we have to square it, multiplied by new h, 0.9 h. So when you compute this, you get the new mass being equivalent to 1.296. 1.296 k r squared h. That is the new mass. Now percentage change in mass will be the new mass minus original mass divided by original, we multiply by 100. We just express it as a percentage. So the new mass will be 1.296 k r squared h minus the original k r squared h divided by the original k r squared h. Now k r squared h can be factored out. We remain with 1.296 minus 1 out of k r squared h, which simplifies out at this point. Remember, we have to multiply everything by 100. Everything by 100. So to make it a percentage now, this is a 0.296 by 100. And this will give us exactly 29.6%. This is the change, but being positive, we conclude that it's an increase. It's an increase. So 29.6% increase. 29.6% increase. Now on series and sequences, we got a question here, which is number 10. The first, the second, and the sixth term of an arithmetic progression are the 3 consecutive terms of a geometric progression. If the first term of the arithmetic progression is 2, find the common ratio of the geometric progression. We're supposed to know how a certain number of terms is obtained from arithmetic progressions. Any of the term generally is given by a plus n minus 1 multiplied by d. So when we are talking about the first term, we can let it to be a. The first term equals to a. The second equals to, when we go to the formula, it will be a plus 2 minus 1 multiplied by d. So it's just d. Then the sixth, which is going to be a plus 6 minus 1, 5 multiplied by d. Now these are the terms. We are told that they follow one another. They are consecutive in a GP, which means they can give us what we call a common ratio. If they can give us a common ratio, then it means the second term, that is a plus d, when divided by the first one, it will be the same as when we take the third one, the third, which is sixth on the other side, divided by a plus d. Now we can cross multiply and have a squared plus 5ad. This is equivalent to ad squared, which is a squared plus 2ad plus d squared. So when we group like terms together, you discover a squared and a squared cancels. Then 3AD is equivalent to D squared. D can cancel out and we get 3A being equivalent to D. So that the value of D can be given as 3 multiplied by the value of A, which is 2. Remember, we are told that the first term of the arithmetic progression is 2. So we substitute 2 at that particular point, we are getting 6. If D is 6, now we can get all the terms. We can get all the terms. The first one is this one, 2. The second one is A plus D, which is 8. The third one is A plus 5D. So 5 by 6, that is 30 plus 2, 32. Now we can get the common ratio whereby we need 8 over 2 or 32 out of 4. 32 over 8, sorry. 32 over 8. Sure, 32 over 8. We'll discover that R is equivalent to 4. So for that geometric progression, the value of R is equivalent to 4. Yeah, it's equivalent to 4. Number 11. Number 11 is on probability. Probability is again another serious area when it comes to mathematics paper 2. Students are supposed to follow it keenly. So make sure you practice enough. Practice enough on probability. Remember also to share this lesson with friends. Remember to subscribe and invite people to the lesson. Number 11, a bag contains 10 balls of which 3 are red, 5 are white, 2 green. Another bag contains 12 balls of which 4 are red, 3 are white, and 5 are green. A bag is chosen at random and a ball picked at random. Find the probability that the ball chosen is red. Find the probability that the ball chosen is red. Probability of picking a red ball. You know, it can be red from the first bag or red from the second bag. So we need probability red from bag A or probability a red from bag B. This means from bag A, we are first of all picking the bag half multiplied by picking red from it is going to be 3 out of the total, which is going to be 10. Or in the second bag, half the probability of picking the bag, because probability of picking either of the bags is just half. So half multiplied by, now picking red from this one, it's going to be 4 divided by total bags, which is going to be 12. Yeah, total bags are 12. Total bags are 12. So this computation is going to give us 19 out of 60. 19 out of 60. So that is the probability. 19 out of 60. There is another interesting question here from a very interesting question from trigonometry. Actually, I encourage learners to work out a lot of trigonometric problems. They are really going to help you. They are going to help you in a big way. It's good to know trigonometric concepts. Okay, solve the equation 6, the cosine squared of x plus 7, the sine of x minus 8. This is equal to 0. The value of x is ranging between 0 and 360. For us to solve this question, we're going to apply the trigonometric identities. The identities will be applied in such a way that we need to say that sine squared of theta plus the cosine squared of theta is usually 1. It's usually 1. So applying this concept now, we're going to say that the cosine squared of theta is equivalent to 1 minus the sine squared of theta. So we replace it at this point now and say this is 6 to 1 minus the sine squared of x instead of cosine squared of x now. 1 minus the sine squared of x plus 7 sine x minus 8 equivalent to 0. So this is 6 minus 6 sine squared of x plus 7 the sine of x minus 8 equals to 0. Now at this point now we can talk of, at this particular point, we can say that the sine of x can be let to be t. If the sine of x can be let to be t, now we will say that 6 and 8 can be grouped together to be negative 2. So we will have negative 6 t squared plus 7t minus 2 equals to 0. Minus 2 is after I have grouped 6 and negative 8. So we can take to the other side 6t squared minus 7t positive 2 equals to 0. So we have our equation now being quadratic, and we can get the values of t, the several values of t, whereby we need product of a by c, 12, sum the value at b, negative 7. So this is negative 3, negative 4. Yeah, these are the two factors multiplied, positive 12, added negative 7. So 6t squared minus 3t minus 4t plus 2 equivalent to 0. In the first two, we can factorize 3t into 2t minus 1. Yeah. And in the other two, I factorized negative 2 such that I remain with 2t minus 1. Yeah, 2t minus 1 actually. 2t minus 1. This is equal to 0. From the brackets, we are getting 2t minus 1 as the common factor. Outside the brackets, there is 3t minus 2. This is equal to 0. Yeah, that's equal to 0. So at this point now, we can say from the first factor, 2t equals to 1. 2t equals to 1. When we take these and we equate to 0, then 2t equals to 1 and t becomes half, or 3t minus 2 equals to 0. So 3t equals to 2. The value of t becomes 2/3. So we can say from these two, the value, whatever had been let to be t is the sine of x. So you say if sine x equals to t, sine x equals to half, then x shall be the sine inverse of half, whereby x becomes 30 degrees. That is the first acute angle. Again, we can say sine of x equals to 2/3. So x shall be the sine inverse of 2/3, giving us x as an acute angle equivalent to 41.81. 41.81 degrees. Yeah, 41.81 degrees. So all the possible values of x now will be 30 degrees, 41.81 degrees, and the same acute angles in other quadrants where signs are also positive. For example, 30 degrees measured in the second quadrant will be 150, and it will have the same trigonometric ratios with 30. 41 measured in the same quadrant becomes 138.19 degrees. So these are all the angles. Those are all the angles that we needed within 0 and 360. Number 13. Again, a very good question. A very good question. In the figure below, ABC is a tangent to the circle BDEF at B. BC is equal to 17, just as you can see, centimeters. DC equals to 10 centimeters, as you can see. BG equals to 15 centimeters, as you can see. Then we are told that the chord FD that you can see, intersect with BE at G, such that the ratio of F to G is to GD equals to 1:5. Equals to 1:5. Equals to 1:5. Find the length of GD. The first thing to find is the length of G to D. G to D. Now we are supposed to know something. We're supposed to know something here. That when chords are intersecting externally, then when we take the whole length FC and we multiply by the outer portion DC, we are supposed to get the tangent squared, BC squared. So FC is unknown, multiplied by 10 DC, we will get 17 squared. So that FC will automatically be, 17 squared is 289. So we get 28.9. 28.9. With this knowledge now, these are centimeters. With this knowledge, because we have divided by 10, 289 over 10, that is supposed to be understood. Now, with that length, we're supposed to know that now, you remember the length we are supposed to get is GD. GD. So we're supposed to tell ourselves that the length FD now, the length FD, because FC is 28 point, then FD is supposed to be 28.9, subtract 10, we get 18.9 centimeters. 18.9 centimeters. Now we are given a ratio of FG is to GD. If we let this one be X, then GD is going to be 18.9 minus X, because the total of FD is 18.9. So we can say X out of 18.9 minus X, this is equal to the ratio of 1/5. Yeah, the ratio of 1/5, because the ratio is 1:5. And with this information now, 5x equals to 18.9 minus x. So that 6x equals to 18.9. 0.9, and the value of x can be found to be, when you divide through, x is going to be 3.15. 3.15 centimeters. Now remember, x is the length fg. So for us to get GD, now, we need to take 18.9, we minus x. Then this is exactly going to be 15.75. 15.75 centimeters. So that is the length that we intended to calculate. The other one is GE, length GE. Now we are supposed to know that now we are dealing with intersection of chords, but internal intersection of chords, whereby in this particular circle now we can say the length FG multiplied by GD should give us the same product as BG multiplied by GE. BG by GE. So the length that we don't know is GE. FG equals to 3.15. GD equals to 15.75. This is equivalent to BG. BG is 15 multiplied by the unknown GE. So to remain with GE, you divide through by 15, and the value of GE becomes exactly 3.3075 centimeters. 3075 centimeters. So that is a question which requires a student to have serious content. Student is supposed to know how these things are done. Yeah, you're supposed to know how the things are done. Thank you. Thank you for following. Remember to subscribe. Remember to share with your friends. Just remember to invite people to the broadcast. Okay, part 14, as we wind up with the section 1. The other lessons now which are remaining, we're going to be discussing section 2s of mathematics paper 2. A rectangular floor measures 4.1 meters, by 2.2 meters. If a possible error of 0.01 meters was made in both measurements, calculate the percentage error. Calculate the percentage error in the calculation of the area of the floor. With the calculation of the area of the floor. Let's look at this question now. We are told that a possible error. So the possible error which was incurred should be divided by 2. It means it was measured to an accuracy of 0.01. Therefore, we should take an absolute error in all the measurements of 0.01 divided by 2, 0.005. 0.00005, so that now the length, which is 4.1, the length becomes, the upper limit will be 4.1005, and the lower limit shall be 4 point, sorry. When we subtract that, it will be 4.095. 9 5. Yeah, 0 9 5. Then the other one is remember it is 3 decimal places, sorry, so it's 0 5. Yeah, those are the limits. About the width, which is 2.2, the same accuracy, so the upper limit will be 2.205. The lower limit will be 2.19195. Yeah, so with all this now, we can talk about absolute error. Okay, we can talk of maximum, minimum. Area minimum shall be when we take the lower limits 4.095 by 2.195. This minimum area shall be 8.988525 square meters. Area maximum shall be when we take the upper limits multiplied by 2.205. This is going to be 9.051525 square meters. Then there is actual area. Actual area is going to be when we take the dimensions as they have been listed. The length by width as they have been listed, 9.02 square meters. Now we can talk of absolute error in the computation, which is given by maximum minus minimum divided by 2. This is going to be 0.0315. Then the other thing which is calculated here is relative error. Relative error is usually computed by absolute error out of actual area. 0.0315 out of actual 9.02. This computation will give us a relative error. Then finally, percentage error, which is given by relative error times 100. So the relative error multiplied by 100. This is going to be exactly 0.3492%. Remember, we've been instructed to calculate the percentage error. It's good to keep an accuracy of 4 significant figures, more so when the accuracy has not been specified by the examiner. When the examiner has not specified the accuracy, kindly get used to 4 significant figures. Just to get used to 4 significant figures. We got a number 15 here on proportional divisions of lines. A very good question, which I expected learners to be knowing. Yeah, and I hope this video is going to help you to understand it. Given that the vector OA equals to 3i plus 2j minus 4k, and vector OB equals to 4i plus 5j minus 2k, then we also told that P divides AB externally in the ratio 3:2. Determine the position vector of P in terms of I, J, and K. Okay. So what we need to do is to ensure that You know, we use what we call the ratio theorem. So we shall say that this is A, this is B, and this is P. Now, P divides AB externally in the ratio 3:2. That means from A to where P is, there are 3 units. You must know how to interpret an external ratio. There are 3 units from A to P. Then we get backwards for 2 units. This is to simply mean that B is at a point here, such that with 3 units and backwards 2 units, we shall remain with 2 units here, and there remains 1 unit here, because it is from A to P 3 units and backwards 2 units, which means it's 2 units between P and B. Then there remains 1 unit between A and B. So with that information now, we can say that in case we had unknown ratios, say even m is to n, then we usually say that ratio m out of all the total proportions m and n multiplied by p, then we add ratio n out of m plus n multiplied by a. This should give us the coordinates of b. And if this is so, then we need to say that b, the coordinates of b, which are, we extract them here, 4, 5, negative 2. So 4, 5, negative 2 equals to m, which is 1, out of total, which is 3, multiplied by the vector p. P is unknown, x, y, z. Then we add 2 out of 3 multiplied by the vector a, which is 3, 2, negative 4. Yeah, that way. Then now from the x components, you can say 4 equals to a third x plus 2/3 by 3. That gives us 2. So we can say the value of x, when we say a third x equals to 2, then the value of x shall be 6. And for the y components, then we will be having 5 equals to a third y plus 4/3. So a third y equals to, a third y is going to be, we take 5 minus 1 and a third. 5 minus 1 and a third gives us a 3 and 2/3. So that the value of y now has to become 11. And finally, using the z components, negative 2 is equivalent to a third z minus 8/3. Minus 8/3. When we group the terms together, it will be, you know, this is 2 and 2/3, but taken to the other side, it will be added. So a third z equals to 2/3, because it is negative 2 plus 2 and 2/3. Then we will say the value of z will be equivalent to 2. And so the vector p now will be given by x, which is 6i plus 11j plus 2k plus 2k. So that is how we use the ratio theorem to determine the coordinates of unknown vectors. Finally, we got the number 16, which says the table below represents a relationship between two variables q and R connected by the equation Q equals to AR plus B, where A and B are constants. On the grid provided, draw the line of best fit. Draw the line of best fit. So the line of best fit can now be drawn. The line of best fit can now be drawn with the way the equation has been given. Then Q is supposed to be on the y-axis. So on the y-axis, we can use intervals of 1. Yeah, allow me use intervals of 1. So 1, 2, 3, 4, 5, 6, 7, 8. Such a scale. We are going to have Q here. Then R is going to lie on the x-axis. We can use intervals of 0, 1, such that from 0, 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, 0 0.6, 0 0.7, 0 0.8, and do it up to there. Okay. The first coordinate 0 0.1, 2.7, 0 0.1, 2.7. The next one 0 0.2, 3.4, 0 0.2, 3.4. So 3.4 is a coordinate at that point. The other one is 0 0.34, 0 0.34 at this point. The other one is going to be 0 0.4, 4.8, 0 0.4, 4.8, 4.8 shall be there. The other one is 0 0.5, 5.6, 0 0.5, 5.6. That one shall be there. The other one is 0 0.6, 6.2, 0 0.6, 6.2. So 6.2 is a coordinate at this point. Now, this graph can simply be drawn by connecting majority of the dots and to see whether they are going to fit on the line. Majority of the dots, and we see where they are falling. Yeah, this is a line of best fit, a line which accommodates majority of the dots. Now, with such a line of best fit, we can use it to determine the value of B. Remember the general equation connecting them. The Q equals to A R plus B. A R plus B. That means because this one is on the x-axis, this one on the y-axis, then it means the coefficient of whatever is on the x is giving us slope. So gradient will give us A, then y-intercept. Y-intercept will give us the value of B. Now from the graph, y-intercept is exactly going to be 2. The y-intercept shall be 2. If A was to be calculated, then we would have gone for the gradient of this particular line. At that time now, we'll be focusing on the section 2 of these examinations, and I believe you'll be found around following keenly. So thank you so much. Subscribe and share.